Okay students, welcome to the new video related to the Johnson's method of optimization or the design. So we have seen in the last video that what are the steps in Johnson's method. So first step was to decide the independent geometrical parameters. Second step was to decide the objective of the design parameters of the optimal design. We need to write the PDE. In the next step, write all subsidiary design equations and the limit equations. Classify the parameters as per the status in problem. Then we need to combine all SD with the PDEs to develop the new PDE. Combine limit equations in PDE to obtain the final PDE, and from final PDE identify material group and select optimum material from it. Determine values of the parameters using the original SDs. Now we'll take an example of the particular bar, that is a tensile bar of length 200 mm is subjected to constant tensile force of 5000 Newton. If the factor of safety is 3, determine the bar with the objective of minimizing the material cost out of the following material. So these are the following materials are given, that steel, aluminum alloy, titanium alloy, magnesium alloys, and the mass density, material cost, yield strength, these are given. Now the first step will be a selection of geometrical parameters. So how we can select the geometrical parameters? We can assume that Cm is then material cost of the tensile bar, then C is the cost per unit mass for the bar material in kg per rupees per kg. Then rho, we can say the mass density of bar material in kg per meter cube. A is the cross section area of the bar in meter square. L is the length of the bar in meter. F is the tensile force acting on the bar in Newton. Fs is the factor of safety. Then rho t is the tensile stress. Sigma t is the tensile stress induced in bar in Newton per millimeter square. Then or we can say meter square. Then SYT is the ultimate strength of the bar in Newton per meter square. Now on the basis of this, we will first write down the equation, that is a PDE equation. So here the we need to decide the optimum design, like weight, cost and the strength. So here the cost we need to reduce, minimum cost we need to select. The most significant undesirable effect to be minimized is the material cost of the bar, that is Cm. So Cm, here the Cm we need to minimize. So we need to minimize the Cm here. So that Cm, how we can minimize the Cm? So for writing the equation for Cm, that's the first PDE we need to write. So first PDE we need to write. So Cm equals to here material cost of the tensile bar, that is C means cost per unit mass into mass of the particular bar. So we know that the mass is nothing but the rho into volume. Volume is cross section area into length. So rho area length. So this is your PDE equation. This is your PDE equation. Now how we can write the SD equations? So SD equations means subsidiary design equations and the limit equations. So subsidiary design equations like your sigma t means tensile stress is given. So tensile stress induced in bar is sigma t, and stress equals to force upon cross section area. So sigma t equals to Ff on A, and we know that the limit equation for sigma t is equals to SUT upon NF, ultimate tensile strength upon the factor of safety NF. So this is the SD equation and this is a limit equation. Now we need to write down a table. So first we write in rows that function required parameters, undesirable parameters, geometry parameters and material parameters. So we have these parameters. Now according to this functional, undesirable, geometrical and the material parameter, we need to write all these in specified parameters, limit parameters, and unspecified and unlimited parameters. So first we need to classify all this. Now this f is a specified parameter because already it's in given in. Okay, so therein then uske baad factor of safety is given, nf is given, so it will be a functional required parameter, but as in specific or specified parameter. Then sigma t is an undesirable effect parameters and it is given, so limit is given, so sigma t will be in undesirable effect parameters, so that is limited. Then cm is an undesirable effect parameter, but it is unspecified and unlimited, it's not specified. Then this is done, this is done, this is done, this is done. Then area is an unspecified parameter, but it's a geometrical parameter, so that's why we will write it here. So geometrical parameter is an area, it's an unspecified unlimited, but length is given, it is limited, that length is given, that is 200. So L is given, geometrical parameters, that's right, is limited parameter. Then sigma C rho SYT, these all will be the material parameter. So C is your cost per unit mass, then rho is the density, SYT is ultimate tensile strength or yield strength, we can say that. Now limited parameters, so we are written like this. Then unlimited parameters will be your Cm equals to C into rho AL. So this is a PD, we already written there. So the SD was the your sigma T equals to force upon area. So instead of writing this area, so area will be replaced by the F upon sigma T. Okay, so here that C will be C into rho into area. Area is where sigma T, sorry, not sigma T, F upon sigma T into L. So this will be your new PD. Okay, so this is a new PD, or we can say developed PD. So sigma C rho FL upon sigma T. Now from this developed PD, what we can say, what we can write, so this developed PD. Okay, so from this developed PD we can see the effect of limit parameters or limit equation can be included in the PD. Therefore case of normal specification is impose LE. LE means your limit equation. So limit equation are there. So this was the limit equation, sigma T equals to SUT upon NF. So that will be imposed here. So sigma T equals to here SUT upon NF. So SUT upon NF will write it here on imposing on the PD. So new developed PD will be your sigma C, that is Cm equals to C rho FL upon sigma T into Cm. Here the Cm is directly proposed to 1 upon sigma T. Okay, so all these values will be in constant, and we know that the sigma T is given here SYT upon NF. SYT upon NF, that is an upper limit, we can say. Okay, now this imposes PD LE on the PD. So LE on the PD, so developed PD will be Cm C rho FL upon sigma T. So limit equation, we know that the sigma T will this, so this will be implemented here, or we can put all the values of the here. So new Cm equal to FLNF into sigma rho SUT. These are all specified parameters. Okay, this is material selection factors. This is called as material selection factors. Hence to minimize the Cm, MSF should be minimum. So this C rho SYT should be minimum. So we need to find out this C. So we already know that these values Fn, so that we will put here. So constant will be 3000 into this. For all